Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 4.6 guided notes on square roots and cube roots. Now, I want you to be aware that some of this video may have been recorded back in spring of 2020 when school shut down, so if you hear any references to specific assignments for the week, or you hear me talk about spring of 2020, again, just using some of those materials that I created then. But this is going to include square roots, something we've talked about before. We're going to talk about squaring numbers. We're also going to talk a little bit more about cube roots, which might be something that is new for you. We'll also mention a little bit about fourth roots, fifth roots, and things like that. Not something we do here, but this is going to set the foundation for some of the things you'll learn next school year.
So I'm going to talk first about what perfect squares are. I'll mention this word later on in the lesson as well. These are numbers that are the squares of integers. So examples of perfect squares include 1, 4, 9, 16, 25, 36, 49, and so forth, which we get because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. They're numbers that when we square an integer, we square a whole number, we get that value. Why are perfect squares important? Well, if we take the square root of a perfect square, we will get a whole number. And we'll talk a little bit about that as we go to estimate some square roots, which is something that is new for you. So you've seen the square root key before. We did it when we talked about Pythagorean theorem. We call this the radical sign. It looks sort of like a check mark here. A square root is one of two equal factors of a number. It's specifically defined in math as if x squared equals y, then x is a square root of y. So if I take the square root of y, I get x. Kind of a weird way to look at it. Every positive number has a positive and a negative square root. Now, when we were back in a previous unit, when we did Pythagorean theorem, we only did the positive value because we were talking about side lengths of a triangle, but we may see some negative values as well because, for example, if I have x squared equals y and I tell you that x squared equals 16, then x could be positive 4 because 4 squared is 16, or it could be negative 4 because negative 4 squared is also 16. This bullet is important here. You cannot take the square root of a negative number. The square of a number cannot be negative. So if I take any number and I raise it to the second power, it cannot get me a negative value. So if I say, what's the square root of negative 8? What's the square root of negative 4? What's the square root of negative 2,000? We will say that there's no real solution. We also say does not exist, so we'll talk about that in a few moments. But if you are asked to find the square root of a negative number, write no real solution, write does not exist. Those are interchangeable. It is just not possible. If you try to take the square root of negative 5 on your calculator is going to give you an error message. A square root of a number that is not a perfect square, like the square root of 8, the square root of 12, the square root of 17, will be an irrational number. And remember, that's a decimal that goes on forever without any repeating pattern to it. So we'll see some of those examples here. I did put down below here, by the way, the perfect squares up to 144. I have had students memorize the perfect squares up to 400 before, which would be 20 squared. It's not a bad idea to know some of the other ones like 13 squared, 14 squared, 15 squared, and so forth. If you want to add those onto the list, you certainly may. I also put the perfect cubes there as well. Because we will see some examples at the very end of this lesson when we go to find cube roots. So a cube root looks like the square root, but it has a little 3 outside to show that it's a cube root. It's one of 3 equal factors of a number. Now what's important here is that you can have cube roots of negative numbers, unlike square roots, which you cannot. So if I say what's the cube root of negative 64 or the cube root of negative 8, those do exist. In fact, the cube root of a negative number will be negative, and each integer has exactly 1 cube root. So if I take x to the third power and I get 8, there's only one solution to that, and that is 2. Whereas for square root, if I say x squared equals 16, I have 2 solutions, 4 and negative 4. So let's go into our first set of examples where I ask you to find the square roots of some numbers without a calculator. So square root of 25, what I'm thinking is, what number to the second power or multiplied by itself gets me 25? Well, that happens to be 5. 5 to the second power is 25. Square root of 49, what number raised to the second power is 49? That's 7. We're going to go through these quickly because these are easy. Number 3, negative square root of 169. So this is just off of our list of perfect squares. But if you recognize that 13 to the second power is 169, then you will know that the negative square root of 169 is negative 13. The negative is okay outside the square root symbol, just not inside. Number 4, this is a new symbol for you, probably. It's a plus or minus symbol. We say plus or minus, that's the way we read this. Basically, you're just going to put it on your answers. When I say plus or minus the square root of 9, the square root of 9 is 3, so I write plus or minus 3. What does this mean? It means that it could be positive 3 or negative 3. You do see this symbol sometimes in real life. Anytime there's an election coming up, a lot of times they'll come out with polling data, and it might even say like the percent of error or the amount of error will be like plus or minus 5%, meaning that that candidate's percentage of their votes could be above by 5%, or it could be below by 5%. So you could add 5%, or you could subtract 5%. So there's a little bit of wiggle room in terms of percent of error. So this symbol I have seen in real life. Again, you just put it right in front of your answer. Number 5, negative square root of 100. So the square root of 100 is 10. Just pop that negative sign in front. Number 6, plus or minus the square root of 144. Square root of 144 is 12. Pop that plus or minus symbol right in front. Number 7, the square root of x squared. You might realize that this is x. For example, if I write 144 as 12 squared and I take the square root of it, I get 12. So if I have x squared and I take the square root of it, I get x. Taking a look at number 8, the square root of negative 64. So what number squared gives you negative 64? Well, hopefully you realize that there is no number that when you multiply it by itself will get you negative 64. 8 to the second power is 64, positive, and negative 8 squared is also positive 64. So we say either no real solution, does not exist, something to that effect. I know, unfortunately, this had to go to the next page. I wasn't able to fit it on the same page, so this is the top of the next page. The square root of a negative number does not exist, except in the imaginary number world. So, like I said, when you try to take the square root of negative 64, your calculator is going to give you an error message. But when you go into Algebra 2, you will talk about the imaginary number system, and you will actually get a value for the square root of negative 64, but it involves something we call imaginary numbers, and those do exist, oddly enough. All right, so I know this says do now, but what I'm going to have you do at this point is pause the video and try these 4 questions on your own. All right, so if you want to find the square root of negative 121, hopefully you realize that that is negative 11. Plus or minus square root of 64 is plus or minus 8, not square root of 8. Square root of 49 is going to be 7. We actually saw that already. And then number 4, square root of negative 16, the big box probably gave it away. This is no real solution or does not exist. Again, if it were the square root of positive 16, you'd get 4, but not the square root of negative 16. All right. The next set of problems is probably new for you. So it says estimate each square root to the nearest integer without a calculator. So in number 9, when it says the square root of 32, 32 is not a perfect square, but I can think of perfect squares that 32 is between. So for example, 5 squared is 25, 6 squared is 36. 32 is between those two perfect squares. So what does that mean? It means the square root of 32 is somewhere between 5 and 6. But because 32 is closer to 36 than it is 25, that means the square root of 32 is closer to 6. It's about 6. Number 10, square root of 62. So 62 is not a perfect square, but 64 is, and 62 is pretty close to that. 49 also is a perfect square, so I know it's between 7 and 8. but 62 is really close to 64, so it means that we can approximate the square root of 62 as about 8. Number 11, negative square root of 18. So I ignore the negative. 18 is not a perfect square, but 16 is, as is 25. So this is going to be between 4 and 5 because 18 is closer to 16. This is closer to 4, but put that negative sign in front of it, so it's about negative 4. I know these are tough. These are not easy questions. Number 12, square root of 175. So this is a little bit above our range that we had, but if you recognize that 13 squared, we already mentioned that, is 169. 14 squared is 196. I remember this one because you basically reverse the tens and ones digit here to get 196. So I know it's between these two, which means it's between 13 and 14, the answer to the square root of 175. Because 175 is closer to 169, we're going to approximate this as about 13. Number 13, negative square root of 120. So 121 is a perfect square, and 120 is pretty close to that. In fact, 11 squared gets us 121, 10 squared is 100, 120 is really close to 121, so this is going to be really close to 11. We'll put the negative sign in front, so about negative 11. And then finally, number 14, the square root of 83. 83 is not a perfect square, however, 81 is. So 9 squared is 81, 10 squared is 100. What this means for us is that we can approximate this square root to be about 81. Or sorry, about 9, not 81. We want to take that base instead of the perfect square. Now, I will put a few of these on your assignments. And again, I know you're looking at some of these and probably thinking, I'm a little unsure of this. That's okay. Students do struggle a bit with this, even when we're in a regular classroom setting. Just try your best. Double check it with a calculator when you're done, but it's not a bad idea to try them again without a calculator because number sense is something that is very important to have. Now, we've already done square roots in the calculator, but I want to remind you where those keys are because the next set of problems asks you to find the square root of numbers using your calculator. So this is the calculator we had in the classroom. And I took the most commonly used calculators. This is not all of them by any means. But the square root key is above the x squared key. It's right here. So in order to plug in a square root, you do the second button, then the x squared key, square root sign will pop up, you put a number in, hit equals, it'll give you a decimal. This is another Texas Instruments calculator. It's in the same position, so you're going to do second and then the x squared key, but your answer may not give you a decimal. It might give you something that is either the same square root, so it might say square root of 11, which you don't want, you want a decimal. It might give you, let's say, something like 3 root 2, which is not bad. It's actually giving you simplest radical form, something you'll see in algebra next year. I think it's actually unit 1. It's been a while since I taught algebra, but it's pretty early in the school year. It's this button that you want to hit. We've talked about this button before, but if you press this button, it will give you a decimal. This calculator, I think a few of you might have had this one. You actually have to put the number in first and then hit the square root key, and then that'll give you your solution. That one's a little different just because you put the number in first. And then the Casios, they're all very similar. So the square root key is right around here. And if you don't have one of these calculators, just look for your square root key. But again, it might give you a weird looking answer like this, and you may want a decimal. So you'll hit this button, the S to D button. It'll convert it to a decimal for you. So why don't you try these next 6? You do not need to plug any of these other symbols in, the negatives or the plus or minus. Just plug in the square root, put the symbol on the front. So number 15, when you do the negative square root of 141, you should get about negative 11.9. Again, I don't put in the negative sign. I just do square root of 141, and then I put the negative sign on my final answer. Square root of 0.5, it's actually going to become bigger because we multiply it by itself. So 0.7 times 0.7 is about 0.49, which is 0.5. So we get about 0.7 because we are rounding this. Plus or minus square root of 89. Don't bother trying to find a plus or minus key on your calculator. Just plug in square root of 89. You get about 9.4. Put the plus or minus sign in front. Square root of 490. Plug that in your calculator. You're going to get about 22.1. Negative square root of 5.08. Plug it into your calculator. You're going to get about negative 2.3. And again, just plug that negative sign in front. And the square root of 1,125, you're going to get about 33.5. Again, if you accidentally put the negative sign underneath the square root, you will get an error message. So be very careful with that. So I want to talk about the cube roots key on our calculator, although the next set of questions that I'm going to give you, there's only 3 more. I'm asking you to do them without a calculator, but I want to talk about where the cube root key is. So if I'm using the calculators we had in class, it's the one that has the X outside the square root sign. So it's actually above the upside down V, and it's above where our regular square root key is. And I remember saying, like, when we talked about square roots, like, do not use that button because it's really only used for cube roots, fourth roots, fifth roots, and so forth. And you actually, if you're going to do a cube root, you have to put the 3 in first, then hit second and the upside down V, and you'll see like the little like square root key pop up, and then put your value in. Why do we put the 3 in? Because we're doing a cube root. So if we were doing a fourth root, you would plug in a 4 first. If you're doing a fifth root, you'd plug in a 5 first. Technically, you can use this key for a square root if you put a 2 in first and then use that key. For this version, it's pretty much the same thing, second, and then this guy, but put the 3 in first. I'm not as familiar with this calculator, so you may need to play around with it. But again, I think you probably put the 3 in first, hit second, and then this key, and then plug in your number. But it may be something where you might want to play around with it. I mean, you guys are pretty good with technology, so try a couple of different things and see what works and what doesn't, especially once you know what the answers should be. For this calculator, you actually have a cube root button. It's above the square root key. You have to hit shift because it's yellow, and then this guy, and then plug in your number. For this one, I don't believe you need to plug in the 3 first because this should just be a cube root. This button you might notice, if you're going to use this guy, which you'd have to hit shift first to get this, you would need to put the 3 in then. I think you can put it in after because you can use this guy to kind of scroll around, sort of like a video game. So again, these are things to play around with. These are things that it's nice when we're in the classroom and we can, play around with as well. I'm mostly familiar with the ones we have in the class because that's the version that I use. But, if we're in the classroom, this is something I can generally help you guys out with as well. So these 3 I asked that you do without a calculator, but if you want to double check it with a calculator to see how it works, feel free to do that. Again, this is your chance to kind of play around. It's a different way to learn stuff, but it gives you a chance to kind of figure some things out on your own. So number 21, when I have the cube root of 27, what I'm trying to think of is what number to the 3rd power gets me 27. 27 is a perfect cube, so I made it easy. If you memorize that sheet at the very beginning of the guided notes, the first page, makes it pretty easy for you. So I know like 1 times 1 times 1, that's going to give me 1. 2 times 2 times 2, 8. 3 times 3 times 3, 27. So what does that tell me? It tells me that the cube root of 27 is 3, because 3 to the 3rd power is 27. Number 3, the cube root of negative 64. So I'm trying to figure out what number multiplied by itself 3 times gets us negative 64. Well, let's ignore the negative for the moment. I know 3 times 3 times 3 is 27, so I know it has to be bigger than 3. So what about 4? 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Well, it means that my answer is 4, but it has to be negative 4. And it's okay for it to be negative here, because I know that negative 4 times negative 4 times negative 4 is going to give me a negative answer, and it'll be negative 64. Finally, number 23, last one for this week's lessons. I know I've given you a lot to think about this week. I'm thinking of what number to the 3rd power gets me negative 125. I know it's higher than 4, so let's go to 5. 5 times 5 is 25. 25 times 5 is indeed 125. So guess what? My answer is negative 5. We're going to begin with question number 24 from those guided notes. It asks us in these problems to replace each blank with less than, greater than, or equal to make a true statement. You may use a calculator for these problems, so hopefully you have one handy, or at least can use your cell phone calculator or your computer to calculate these. So number 24, we're comparing the square root of 34 to 5 3/8. So the square root of 34, which I plugged into my calculator, got me about 5.83. And I did include 2 decimal places after the decimal point, just to make sure that I had enough to be able to compare the two. 5 3/8, what I would do is do 3 divided by 8, which gets you 0.375. So 5 3/8 is 5.375. So it's pretty easy to compare these two. 5.8 is definitely greater than 5.3, so this would be greater than. Number 25, the square root of 125 I did in my calculator and got about 11.18. 11 7/8, what I did was 7 divided by 8 to get 0.875, although I actually have the eighths memorized, so that makes life a little bit easier. But 7/8 is 0.875, so this will be 11.875, which means that the square root of 125 is less than, ooh, don't move all of that, is less than 11 7/8. Number 26, 3.2 is already a decimal, so I did the square root of 9.5 in my calculator to get about 3.08. 3.2 is greater than 3.08. So once you change them, once you change them both to decimals, it's pretty easy to compare them. Number 27, the square root of 3, I plugged into my calculator to get about 1.73. 1.5 is definitely 1.5. So 1.73 is greater than 1.5, or 1.5. Number 28, I calculated the square root of 7.84 to be about 2.8. And then comparing that to it was exactly 2.8. Comparing that to 2.8 here on the right-hand side means that those two are equal to each other. Kind of forget I had plugged this in or typed these in a couple of days ago. So square root of 7.84 is exactly 2.8. So those two are equal. Now, if this was 2.8165, it would not be equal. So we would just want to be very careful there. Last one of these, number 29, square root of 12, and I plug it into my calculator, is going to get me about, keep moving that, I apologize, give me about 3.46. So 3.67 is going to be, once again, greater than the square root of 12. These are ones, of course, you could certainly try on your own. With calculators, this is just giving us a chance to practice comparing decimals, but also just plugging these things into our calculator as well. All right, let's take a look at the next group of problems, because these ask us to do them without using a calculator. So it says, order each set of numbers from least to greatest. You may not use a calculator for these problems. So the square root of 49, hopefully you recognize that as 7. So I just wrote all of these, or typed all of these up. Square root of 49 is 7. 6.91 repeating, I kept as a decimal. I think it's easiest if we write them as decimals to compare. And then the next one, 7 1/8. Again, I have the eighths memorized, so it makes life pretty easy for me. If you don't, you might need to do 1 divided by 8. 1 is underneath the division symbol, 8 is outside. That's going to get us 0.125, and of course then that will be 7.125. So in comparing these at this point, 6.91 repeating is the smallest, then 7, or square root of 49, then 7.125, or 7 1/8. The last one, 15 over 2, I wrote as a mixed number. That would be 7.5, which is 7.5. So let's put all that together then in order from least to greatest. So the smallest is clearly the 6.91 repeating. Next is 7, which was, I wrote it as it originally was in the problem, which is square root of 49. Next would be your 7.125, which is 7 1/8. And then the largest is our 7.5, which is 15 over 2. All right, let's give number 31 a try. 4 1/3, hopefully you have this memorized. Again, there's some decimals you really should memorize, some fraction decimal conversions. That's 4.3 repeating. Now the square root of 43, I don't know what that is, but I know that it's between 6 and 7, since 43 is not a perfect square. The perfect squares it's between are 36 and 49. Square root of 36 is 6, square root of 49 is 7. So I know it's between 6 and 7. I designed this so you can answer the question without having to, without necessarily having to know what the square root of 43 is. Up next, we have 4.13. Somehow I skipped 12 over 3, I think. So I'm going to have to add that in. My apologies. Sometimes I make some mistakes, and I just recognize that here. But I'm missing 12 over 3. Let me do that. 4.13 I'm going to leave as it is. Let me add this in, so bear with me. Silly mistakes. So we've got 12 over 3, which we know equals 4. So I am going to have to add this in then. To my answer, because I do not think I typed it in as part of that. But 12/3 is equal to 4 exactly. And then the cube root of 27, I do have, that's 3, since 3 to the third power is 27. So when I go to list these in order from least to greatest, my smallest number is going to be the cube root of 27, because obviously that is 3. But I do need to add in, and I'm going to do that here. So up next, instead of putting 4.13 next, which it will go after 12 over 3, this 12/3, let me copy that and see what we do as teachers all the time. So bear with me while I get this guy moved. Let's see if I can move it. All right, so move you down there. My apologies for messing this problem up, but you know, we can fix it, no big deal. So my smallest again is the cube root of 27, which is 3. Up next would be the number 4, which is 12/3. Then we would have 4.13, followed by 4 1/3. They are not equal to each other because, again, 4 1/3 is 4.3 repeating. And then clearly the square root of 43 is going to be the largest since it's between 6 and 7. So again, cube root of 27, 12/3, which I neglected, 4.13, 4 1/3, and the square root of 43. All right, number 32. Negatives. Let's compare these. So -2 is -2. -1.5 is -1.5. -1 8/10 is pretty easy. That's -1.8. It's also the same as -1 4/5. It's just not reduced, but it's -1.8. And then the negative square root of 6. Now, I don't know exactly what it is, but I know that while 6 is not a perfect square, it's between the perfect squares of 4 and 9, meaning the square root of 6 is between 2 and 3. So I know that this is going to be between -2 and -3. So when I go to put these in order from least to greatest, the negative square root of 6 is going to be the smallest since it's going to be beyond -2. Picture a number line, or imagine a number line if needed, followed by -2, then -1.8, which is -1 8/10, and then your largest is -1.5. Remember with the negatives, it's the opposite order of what we would think. And I'm going to try to avoid putting too many negatives on your practice because I know they're kind of tough. If we were in the classroom, we'd probably see a bit more of this, but I realize we're also not in a classroom setting. All right, let's take a look at the last one of these, number 33. We've got the cube root of 8. Hopefully you remember that is 2, since 2 to the third power is 8. 3.3, of course, is equal to 3.3. 12/3, I did not forget about it here, is 4. Had I known or remembered that it was on the next slide, I would have just copied it over. And then finally, we have 3 1/3. We already talked about 1/3. That's 0.3 repeating, so that's 3.3 repeating. So from least to greatest, 2 is the smallest, so that's going to be the cube root of 8, followed by 3.3. 3.3 repeating is slightly bigger than that since 3.3 is like 3.30, and 3 1/3 is 3.33. So 3 1/3 comes next. Finally, our largest is 12/3, which is of course equivalent to 4. All right, so we've got a few more questions to look at. Let's go through these a little quicker. Number 34, it says, Sid says that the answer to negative square root of 25 does not exist, while Pete says that the answer is negative 5. Who is correct? Explain. What do you think? All right, hopefully you recognize that Pete is correct in this case. A negative number can be outside of the square root, but if the negative is inside the square root, then it does not exist. So Sid would be correct if this said the square root of negative 25. That does not exist, but the negative square root of 25 does. Number 35, Grant says that the cube root of negative 1 does not exist, while Brinley says that the answer is negative 1. Who is correct? Explain. What do you think? So if this were a square root, Grant would be correct, but you are looking for the number that when you cube it, you get negative 1. This number is negative 1, so Brinley is correct. If I take negative 1 to the third power, I get negative 1. So I'm allowed to take the cube root of a negative number, just not the square root of a negative number. Finally, number 36, which point on the number line best represents the square root of 84? What do you think? So 84 is not a perfect square, but it is between 81, which is a perfect square, and 100. The square root of 81 is 9. The square root of 100 is 10. So I know this is between 9 and 10. But 84 is pretty close to 81. So I know that it should actually be pretty close to 9. The closest point that is close to 9 but is above 9 and between 9 and 10 would be point C. So what I said here was the square root of 84 is a little more than 9 since 9 squared is 81. So it makes the most sense that C would represent this value. Now, this video went a little longer than I expected, basically because I made that mistake on the one problem, but you get the idea. There is a second video that I want you to watch on solving some equations with square and cube roots before you try assignment 1, but I will put some questions from this video on assignment 1 for you to try. Not a lot, and I'll try to make them as easy as possible given that we're not in the classroom, but I will give you some practice again that goes with assignment 1. Thanks for listening.